Hey, morning or afternoon now. Just got to do a few quick RePCB builds, so I figured I'd just jump on camera and get them done. So it'll only be like an hour stream, but just got to get a couple of these built, so I figured I might as well hop on. I've been away for a couple of days now, so I'm just catching up on everything before we get going again. Clean screen off this. You have to just let me know if all the stream's still good as well, because obviously I haven't been on for like a week and a bit, and I've moved some cables around and the internet's been changed up and stuff, so I presume everything's still working good, but with not doing it for a little while, just let me know if there's any issues with the stream. So I've got a known working test screen there. We've had as well, this is actually the second faulty RePCB we've had. So we only ever had one that was faulty originally. Funnily enough, almost the very first one I picked up out of the production ended up being faulty, and it was one of these. This cable on was one of these pads on here were joined together, and then this is a second one with a short inside here. So we're just going to strip off the chips off this one and put it on another board. So obviously we're going to, instead of trying to reuse this, we don't want to reuse a board with, you know, like bird marks on. So we're just going to gut this board and start again. Single ASIC board, yeah, I've made one, fully working now, that's just started production. So we've got this one, so this is the one ASIC board. This is obviously the prototype, so bear in mind the wires are just because it was a prototype, so we had to rewire the read and write were backwards to the cartridge port here, so we fixed that, and one of the pins on the video RAM needed to be grounded. Other than that, this was fully working, so we've basically fixed that and sent it into production. And then we've also tested it with a VA45 chip, so the Majesco chips. Obviously you have to hand wire at the minute on the V3, the V4 is going to be plug-in. This was obviously messy just because it was a test, and I wouldn't send it out like this with the wires like that, but this was confirmed fully working as well with VA45, so this one chip board will work with every single one chip Game Gear made. The short on the board, this will just be a one-off issue. We've got through about 400 of them now, and this is only the second faulty board, and I'm presuming it's just going to be an issue with the slight gap on this bend. It might have been a fault when we've been assembling something, but I'm just going to make a presumption this board's faulty and not use it because it's tarnished anyway. But you can get faults on boards even if you're mass produced and assembly tested and stuff. It's just one of them things that can happen. Yeah, stream is looking good. That's good then, because I couldn't remember how to set it up when I got back. You do it daily and you just set up, and then I come back and I couldn't remember where the mic was and how to mute it and unmute it, and I forgot within less than a week what I was doing. Right, so that's when we want to gut on chatting away and putting the ribbons back on the faulty board. Get them off there in a minute. Start transferring these over. Shipping for the one ASICs. I'm getting one more sample made because the quality of the silk screen, you know, the black print wasn't great and the button wasn't soldered well. So I just wanted, even though they're like, it was a hand assembled rapid prototype, I still want to confirm the mass assembly quality is good before I go and you know, produce them basically. So I've got one more sample coming in probably a week that should be the final production quality, and then I'll chuck it into mainstream assembly, so probably 6 weeks away, I'd say. Hopefully less, but more than likely it's going to be a 4 to 6 week turnaround until we've got them listed on the website basically. Is there a modulating board for the modern consoles that makes the PlayStation who can play old gen games? Not quite sure what you mean. I don't really want to try and rephrase that. I'm not really sure what you're asking there. Yeah, the PCB suppliers are mainstream OEM manufacturers. They're not small factories. It's just one of them things, like I say, that must slip by the testing procedure. And plus, bear in mind, these aren't assembled boards from the factory, so they can't fully test them because there's no chips on them. So you know, you can't really test much if there's no full production board ready to go. Yeah, I've had a few smoky boards. This one was smoking. You've missed this one. Please say bottle of water, not bottle of water. No, I think the worst accent for that's like Scousers or Cockneys, but you still couldn't understand water when I used to work in America. I used to have a business over there, and I still couldn't order water from Starbucks. You try to say water and try to say it with like an American accent, and it was even worse. Doesn't matter what I said, I couldn't get water over there, which I don't understand, because to me it sounds normal. Yeah, we're literally out now of 2 ASICs. I've worked through that pile. We've done probably over 100, I'd say. 2 ASICs of all the old stock we had that was like circuit boards were too bad. So we've managed to reuse all of them, and we've got, well, literally I've got two VDPs left now. That's it. So I'm going to have to order some more Game Gears because the 1 ASICs aren't going to be here in time. But I've managed to pretty much use every single board with I don't know how many bad VDPs we've had, probably maybe 20 every 100 we've had, which is quite high, but it could be worse. Otherwise they would have just gone in the bin, but the fact that we've now got a new board, we can reuse them, we've managed to keep them alive. Yeah, like the new consoles can play old ones. It's just more so that obviously that's basically emulation. So like the Switch can play that's hot. The Switch can play the Game Boy games and stuff like that, but it's basically emulating the hardware. Then you've got, I think there's anything I need off there. You've got things like the Analog Pocket, which are on new consoles that emulate the hardware but using FPGAs, which is a bit better than emulation because it's hardware emulation in a way. It's like remaking the hardware, so it's still emulation, but that's as close as you get to not using true original chips, is to emulate the hardware so that it's like cycle accurate every time the clock pulses. The chip should output the exact same thing that the real hardware would do. That's kind of the point of it. I'll tin these up. Yeah, for the soldering, I've had quite a few people. I mentioned it on and off for quite a few times now that people want like training, and they don't mind sort of paying for training, and I could never really figure out the best format for teaching people. But I was considering, do we do like a, obviously you can subscribe, I don't know how to do it, I don't know if it's set up or not yet, but subscribe to like Twitch or YouTube as like a paid monthly sort of, and then I'll run like lives just for the subs, for purposely training people. So there'll be a lot less people on, but it's more dedicated to one-on-one with people and kind of guiding them through specifics, starting with like basics of soldering and working a way up. That's what I'll probably end up doing, just like set up some kind of sub thing at some point, and then a couple of times a month actually run videos just for that are aimed at the, not so much me just sitting here working, but sort of showing you how to do this if you wanted to do it as a career or fix your own stuff up. Especially now I've got all the equipment set up and it's working. Thanks, Jake. I'm sure we'll have some success. We better do. We've only got two VDPs left, and we need 2 consoles, so we need these to work. Yeah, you're welcome. I'm always happy when people use the wiki. That's what it's there for. Yeah, well, let's hope that let's definitely hope these VDPs work. I think one, yeah, we don't actually know. I was going to say, I think one of these worked in the tub originally, but we've since used them, so these are 2 new ones, so I'm not actually sure. I did have one in there with a green dot on that I knew worked, but this isn't one of them, unfortunately. So it's hit and miss whether it's going to work. Let me just disable this camera and re-enable it as well a second. It's gone like laggy again. It seems to be doing that recently. Deactivate. That's it. Activate again. Oh, he didn't like me doing that. Maybe I shouldn't have deactivated that video. Let's try again. That camera's working. I've managed to kill the overhead camera. Yeah, it should be. Should be working. Deactivate again. Activate again. There we go. Maybe I won't try disabling that. Yeah, that's back to normal now. I think the PC is just a bit overloaded with the amount of 4K cameras connected to it. other way with that. The Dolphin for GameCube, yeah, it actually is really good. I was surprised. I didn't think it was going to be good, but it does work quite well. I think it's the best one, to be honest, at the minute for the emulation. Right, let's chuck on Z80. Yeah, I might try swapping. I've got like 4 cam links connected to USB, whereas I do have a PCIe HDMI capture card, but I think it struggles with 4K, but considering we're streaming with 1K, I think that'd be probably better go back to the Blackmagic capture card instead of like tons of USB ports sort of hogging the USB. So when I get time, I'll probably mess with that, and that should hopefully stop it. It just makes this overhead sometimes a little bit slow motion, but nothing seems to crash luckily so far. So CPU first. Yeah, looks close enough. Yeah, we're just doing the usual a RePCB Game Gear. We've got 2 I've just got to get done in the next half hour ideally, so it's just a quick live stream, but hopefully we won't have any issues. Obviously 1 full pin out over here. I'm going to try and knock it into place. That's it. Yeah, it looks alright. yeah, for the caps, I think we do the recap's part of the default service on our Game Gear sending as well. So if you wanted the recap doing, you can just literally book it in under Retro 6 send-ins, then Game Gear, and literally the recap is standard. We don't even work on them without recapping because they all need recapping. Basically, they're all bad. So, moment of truth for the VDP. Yeah, replicating the VDP, the ASIC for the one chip. It's underway at the minute, just mainly ascertaining whether it's financially worth doing. Cause it's going to be a lot. It's going to be a hell of a lot of money to do. But yeah, it's almost certainly possible. So I'm just trying to gauge interest in how many people would want that versus, you know, if we clone the ASIC one for one hardware wise. It's still technically an original Game Gear, but obviously it's something that we'll have made brand new, so it's whether people feel like that is actually you know, you're classed as a Game Gear, I guess, an original Game Gear. But yeah, it's definitely it's something we're working on and deciding at the minute what we do. I think there'll be enough interest, and if not, I think we still sell enough of them that we'd probably still do it as long as it's has a little bit of interest, at least from the community, not just us. Oh yeah, the Sapphires, we're literally building them every day still. Have we got one of them here still, or is it gone now? It's gone down now. Oh, we just sent them all for shipping, so somebody's just had the ones we built up today, but yeah, they look well nice. I don't think there's many left now, to be honest. And then it's obviously a limited run, so we'll maybe do another limited run of another colour, but I'd definitely grab the clear blue Sapphire while you can, because they might not ever come back once we've ended that run and we move on to other limited runs. We might not ever bring them back, even though they're selling really well, but that's kind of the point of the limited run, that we don't plan to redo them once they've run out. It looks clean enough. I can clean up a bit more after, but just check those pins. And I've got the camera nice and sharp enough now, I think, that I don't even need to use the scope most of the time. I can literally see just on screen. So I think that is everything we need. Put them two away. Move them. That away. Yeah, I think it is. Game Gear's not recapped working. We do. You come across them, but they 100% will not last. A Game Gear will boot without any caps anyway. You just won't get the original screen working because the two caps on there that make the contrast circuit work are needed. But you could put two caps on a Game Gear and have the whole thing fully work without any caps at all. So it's not so much that the Game Gears, you know, need recapping because they need the caps. They need recapping because they leak everywhere and destroy the board. So it's more, that's why. And if they still work with the leaking caps, it's just purely that the caps are probably dead. It's just that they haven't leaked or corroded anything yet to make it fail at boot. Yeah, you wouldn't want to hear me sing. GBC with bad power reg board. What you want to do is cut the... have you got a Game Boy Color thingy there, like a PCB? Like already opened, so I don't have to faff opening it. So you want to basically cut this pin here, the top left as it was, but if you flip it over, then it's basically top right, pin 7. So if you cut this here, disconnect this from the board so it's floating, so just literally get snips through there, or desolder this pin off the board and lift, whichever you want to do. Turn it on, and then with your multimeter measure ground on this pin here, and see if these two pins have whatever voltage they should have, I can't remember. Let's boot it up. I think it's positive 13 and minus 19, but you just want to make sure you've got them two rails. Let me just see what they are. And this might not even power up, it's obviously an untested board. That's out. Right, so if we have background for, yeah, just about got ground actually. Right, so right, you want minus, let's zoom in on here now. When you power on, so you're going to have the power switch on, turn that on. You want to measure, this is a good ground point, so you can just tap on this ground. This pin here, so try not to bridge between them, otherwise you'll do more damage. This pin should be minus 14.4 roughly, and this one should be positive 13.3, so roughly 13 to 14 volts. The top one is, like as in the second pin down, negative, this one's positive. If you've got them two voltages, this is normally the one that fails, the 5 volt. You can just snip that pin, solder a clean power over the top, and the clean power will handle the 5 volt rail, and your original regulator will handle the LCD contrast circuit. I do probably plan on making a clean power that does that for you, because we do have some plans for making a more original Game Boy Color in the future, so it's probably something that I'll make anyway with the clean power when I get time. Right then, power up I think. That. USB. Bad VDP. Nice. Shocker. So the usual. Yeah, so that's just a bad VDP. So we're down to the exact 2 we have left. Once these go, we're going to have to order more until the 1 chips are ready. That is so common that happens. It's always the VDP. Rebooting when you turn the brightness up. If you have a clean screen, check if you have these 3 resistors, so it's the latest version. If you do, that's no problem. If you don't, disconnect the clean screen for the test. because that's the first test. It's more than likely a few things can happen. The clean screen can draw too much power, and basically you're powering out the board because it's pulling too much power. The other thing can be the ribbon. So this ribbon, this power ribbon here that attaches to the power ribbon, you might want to replace that if you haven't already, because if that's bad, when it goes under load it fails. Another issue can be the power board itself, obviously, and a final issue can be either the contrast wheel or the contrast circuit can start shorting when you crank up the current. So you can remove, is it an original board or a RePCB? Because I presume it's an original board. And then basically when you crank up the power, part of the contrast circuit can fail. There's a lot more components you can remove that you don't need that can prevent the issue. But the simplest thing would be to completely disconnect the middle 2 pins of the contrast wheel. Just cut all the traces you see around it so that the wheel isn't connecting to anything on the board, and that'll disconnect the contrast circuit completely anyway. But it's basically you're hitting an issue of something over currenting when you're turning up the contrast wheel, or simply the power ribbon or board can't handle the current, and there's nothing wrong with the current, it's just that your power circuit can't handle it. But we've found a few times it's the actual the original PCB that's arcing inside the circuit when the current picks up. Right, he's possibly bad one going on right side, so if I forget later, that's bad over there. Chuck another one on. The VDPs, no, you can't remake the VDPs. So instead of remaking these two, CPU and VDP, the 1 ASICs are just instead a single chip, which is these two combined. So we're thinking of remaking the single ASIC so that effectively that's these two chips combined in one. Yeah, so the two ASICs obviously, hence the 2 ASIC, and it's also the Z80 down here, and then the 1 ASIC combines the Z80, the CPU and the VDP all into one package. So it's obviously the 1 ASIC board that we'll be selling, you'll only have to solder 1 chip on as well, and it'll come with our crystal now, because we've obviously tested enough of these that the mass production ones are fine. So the 1 ASIC, you'll literally chuck the single ASIC on. If it doesn't work, it's then you're soldering all the ASIC. So it's going to be much simpler to do in that respect, but it's also maybe just because I don't have the same practice, but the pins on these are a lot more fine pitch. Look at the difference. So there's quite a difference in the pitch of the 1 ASIC. So it's not necessarily harder to solder, but what I find is it's easier to accidentally bend these pins on the 1 ASIC. So that's the only downside. You've got 1 chip to solder, but these are quite chunky compared to it, so a bit easier to work with. Right, and let's try again. Bad one's over there. The game's still in. There we go. So that's one working. Turn it on. Yes, that seems to be fully working, that one. So now we've got to try and build one more in 16 minutes somehow. Yeah, for the Nomad you can use the Clean Amp Universal, it's called. Little rectangle, and it's just an amp that you can wire ground, power, audio in, and you get an audio out to a speaker, so you can pretty much use it for any console. That one's done. Like that. Oh, there's the other one, just put them on it and go and can't it? Right, so here's another bad chip. So I'm going to keep these bad chips and we'll look at gutting them at one point and seeing if we can do anything with them. Right, so we've got one VDP left to hope that it works. Otherwise, we've got no other Game Gears left at the minute. For PS5 controllers, we don't work on them anymore, unfortunately. It just isn't worth the labour time. And to be honest, they're all going to stick drift over time, so it's like, I'd personally just grab another controller. There's not many people that are going to work on them for a labour cost that's, if the labour cost is too cheap, then you're suspecting they've not got experience, so you might end up with a half job anyway, and if they have got experience, then it's not far off the cost of a controller, so I personally don't think it's worth doing the controller. Yeah, we get the chips literally from Game Gears we buy, eBay, Japanese auction sites, customers that we know. Just get them from anywhere really. Is that the door over there? Yeah. Yeah, that's what I mean with the these counts at the top are like just completely random. Like we'll probably have, there's usually 100 or so on TikTok, 100 or so on YouTube, but the counts, I think the count on the YouTube is just for the horizontal ones, and we get way more viewers on the vertical layout. Like strangely, YouTube is the one place I would have thought the horizontal layout would be popular, but we literally get 10 times more viewers on the vertical layout, but this count doesn't show that. So I don't think the counts are super accurate. It's just, it would be nice to have them accurate, but they never seem to be even remotely. I mean, you can tell me now on the platforms what viewers you're seeing, and then we'd know. Like on TikTok, we don't see anything, so if somebody on TikTok can see what it actually says in terms of live viewer count, to let us know. Same for like YouTube, just fire off what viewers you're seeing on Facebook, YouTube and TikTok, and we'll compare them to what's on screen. I mean, I could write some software to do this properly. It's one of the things I found with the streaming stuff is, considering how popular it is, there's not that much software that I think works that good. Like even today, the chat is still something that's hard to integrate, and I think I'm even paying for this chat thing because I'm using Streamlabs over multiple platforms, and yet it still doesn't work half the time, and it misses off some platforms. So if I ever get the time, I should probably just write the software that works. Same for like the views, like that surely isn't that hard to write a bit of code that pulls the live viewers. We're clean on them. Let's drop a Z80 on. So the Facebook one seems about accurate, and normally, funnily enough, the Facebook one is the most popular. We normally get 20 to 30 views on Facebook. But I haven't been on for like a week or so, so that's probably why we're not, you know, people won't be expecting me to appear because I haven't appeared for a week. Zoom in a bit on that. No, this board, I mean, I only officially support the RetroSix display on this board, just because obviously it's our product, we control the entire process, the QC, we can guarantee it works, but people have wired up every other board on this, I think, pretty much. I could be wrong, but I'm pretty sure they've wired up every other third-party board onto this one. Yeah, so I think the YouTube basically then is missing the vertical count, which, like I say, I think I'll just end up writing some software. If I get, you know, a bit of time at night where I'm free, I'll probably just write some software for the viewers, because TikTok's missing, and that's quite a big one as well. And then it'd be nice to see the YouTube combined views, not just the horizontal, because, like I say, the YouTube is probably the most viewers I've really had in terms of, well, certainly in lives. But YouTube's always been notoriously hard for me to get any views doing, whereas TikTok has always been much more popular for my content. So it's nice to actually see we do have some YouTube viewers, well, quite a lot of YouTube viewers. They just don't show on the view count, so it looks really slow. I thought I'd disabled that long message thing as well, I'm pretty sure I did. So I'm not sure why the bot's telling you off for sending long messages. I'll have to look that up as well. If it's shutting down after 10 minutes, Leonardo, I've just read up and noticed I missed your message. That to me sounds like either something's overheating, so either spray some IPA on the board while it's running, just avoid the TFT screen, or your power board's failing. That's the two most likely causes if it's running for 10 minutes and then powering off. CPU, look how many spare CPUs I've got. That many spare CPUs is because that many VDPs have failed. Oh yeah, the TikTok. It's literally I went from well, I was basically getting more views on TikTok. I probably still would if I posted the format I did before, which is pre-recorded videos. I was getting between 10,000 and 30,000 views every video within 24 hours. That's been the same from 10,000 viewers up to, or 10,000 subs up to, I think I'm on like 50 or 60, I think it's like 50,000 now. But at 10,000 that was more views than most people were getting with a channel 10 times the size. IQ, not a clue. Don't think I've ever taken the test. Probably really low. Top left 3 looks low on solder. Is that on the Z80, I presume? The Z80 never seems to flow very nice on the solder. I think it's because obviously the refurbished chips, and these ones I've taken off consoles with a bit of flux normally, so the pins are nicely flown. But I'll go back and look at it, but it's normally just visual on the Z80. It normally looks worse than it is. But I'll go and check it in a second. How hard is it to learn? Not that hard if you start on things like Game Boys or basic soldering and just work through it. You just build up knowledge. Basically everything's just progression of knowledge. When you see me work on stuff I've never worked on, there's nothing magical about it. I don't know what I'm doing until I figure it out, and you have to work on it a lot more. So you just put more hours in and figure it out as you go, basically, just systematically. Me Netherlands, I know we're in the UK if that was directed to us. Right, let's just check out them pins. Yeah, I see what you mean visually. They look, they look like the low on solder. It's just because the flow, the profile of the solder isn't great, but you can see you can push on them and they don't come off. But that's just, if you were really finicky about making clean solder, then you'd obviously, I'd probably return the pads properly. Yeah, soldering iron's stuck under here a second. So if we reflowed, probably just reflow, we don't even need to add solder. You can see you get that kind of pattern. So you can make the joints a lot cleaner, just running down with the iron and a bit of flux. It visually looks nicer now. But that's just, I'm not that fussed about that level of accuracy on the pins, if you know what I mean. They're soldered on well, and that's the thing that matters to me. Can always do a better job, but I don't want to spend my time too much on making everything look like it's ready for, an Instagram shot, basically. As long as the soldering's solid. And these, you see, reflow much better anyway. These like naturally flow and look really clean. But I suppose similar to that, I'll get that in focus. You can see, like, same thing here, like a little bit of solder that's not there, but if you push on with tweezers, you can see it's rock solid. So it's that compromise between how much time do you spend making it look super pretty, getting them joints like military spec, or getting it so it's functionally soldered, basically. So yeah, we can always improve the soldering joints with reflowing with the iron and flux, but like I say, function wise it's more than good enough for now. Right, and so, oh, crystal, I always forget the crystal. Let me put the crystal on now, otherwise I'll forget. Good place to get Game Boys. Again, to be honest, you get some steals on eBay. You've got Jaws is a Japanese auction site, which is similar to like Sendico. There's a few places. I can't think of the name of it, maybe you guys will know. It begins with M, something like Marcia, I think. I can't remember the name, but it's on, I think that's on Jaws as one of the options. And you tend to buy, I'll buy in bulk off Jaws. I'll buy like 100 consoles at a time, but you can get some good deals for low volume as well. And then another good one is simply finding, I have a few contacts I know just personally as people, when you go like retro events and you meet them, and they'll do the same. They'll probably buy off, again, original people, or they'll have stores with walk-ins, or they'll buy consoles as trade-ins, and you can get good deals if you form relationships with people that say they work on Mega Drives more and they don't really have Game Boys, but they accumulate a bunch of Game Boys over time and then they sell them to you. But in general, eBay is one of your best, because that's where, if somebody owns one and they want to get rid of it, then they're going to go, actually let's move them down there, they're going to chuck it on eBay. That's the first place you'd think of selling it, so you're probably going to find them there. Maybe like, what are the other stores? I don't know, Vinted does clothes, or whether it's got consoles on as well, but you know, maybe the lesser known ones you might find good deals on as well. Right, and this is my last VDP at our shop. So if this doesn't work, we have no more RePCBs until the one ASIC's done, or I buy some more Game Gears. So everybody stay off eBay, because I'm about to rob it of all the Game Gears. No, Game Boys are 10 times easier than Game Gears. Until it sounds a bit big-headed, but until I come about and did the Game Gear reverse engineering on the power board and the VREF circuit, this was only going back 5 years. You used to pick up Game Gears for £5 because, short of putting caps on them, nobody knew what to do with them. If they didn't work, people had no knowledge or understanding of how they worked. So I think I got bored at the I think it's the Donington or Doncaster Retro event. We had a stall there selling stuff, but I don't enjoy the selling side. I like the buying side, so I'd set up a stall to sell stuff, and then when I was sitting there basically waiting for people to come around and buy stuff, I decided to start working through Game Gears and learning how they worked, and that's where I started the wiki. I literally started the wiki with the Game Gear reverse engineering. So now there's a ton of people that have the knowledge. I'd like to think, because a lot of it is from my wiki. So, you know, once somebody figures it out, you share the knowledge and more people can learn how to fix them. So now the Game Gears are much easier to fix than they were, but they're still a lot more complicated than Game Boys. Like, no insult to people that work on Game Boys, but I could teach you how to fix any part of a Game Boy in probably 2 hours. Like, every possible fault you could ever have. They're not that hard, but it's good to learn on, because there's a lot of concepts there and a lot of stuff you've got to learn, and you could spend months learning the Game Boys if you've got no knowledge in the first place. But I definitely think they're a good starting point, because they're complex enough that you have a challenge. So if you don't know something, they are still slightly challenging. Like, say, the Game Boy Color, until you realise the power passes through the DC jack, so the ground passes through there. A lot of people used to struggle on figuring out power related issues with the Game Boy Color not powering on, and then once you look at the schematic and realise the power flows through the DC jack, which is here, so the power flows through pins, I think it's 5 here, and oh no, sorry, this one, isn't it, DC jack, pins 4 and 5 here. When you insert a DC jack, it disconnects pin 4 and 5. So if you unplug the DC jack, pins 4 and 5 short together, but that means your battery spring ground passes through this, and it also is part of the reason why, when you have an audio amp on there pulsing quite a lot of current, that the power turns off, because the power path of this is terrible. It kind of goes from the battery spring down through this, through a fuse, all the way up to the power switch, which is over here. It physically passes through the power switch, so there's a lot of bad design stuff in the Game Boy Color, which, as you learn it, that's something you can learn and, you know, appreciate, but short of that, they're a very simple system to work on. And you can make good money, because they're also the most popular systems. So if you buy faulty Game Boys, like, I could probably make a little living off YouTube, similar to like our Joey Does Tech, that's who I watch on I think it's Twitch or YouTube. Like, mostly buys, say, PlayStation 5s and Xboxes and repairs them for profit. So it's like the same thing over and over. I'm sure we could do something like that with Game Boys, and just all day long buy faulty Game Boys, fix them, chuck them back on eBay as working. But I think my brain would die of rot if I was doing that, because there's no challenge. Have we got everything on this now for boot? I think we have, haven't we? So yeah, GBA SPs, they're probably, I'd say they are currently the most difficult to work on, in the sense that, again, nobody's reverse engineered them fully. And I started doing it on the wiki, and I've done it for like the audio circuit, and I've started doing the PMIC, but I keep some notes personal that aren't yet on the wiki, because I haven't had enough time to prove the knowledge I've done and, you know, share it. But there's not, you know, a full amount of knowledge on how the SPs work. It's just that they don't tend to fail in many ways, so the failures that happen are kind of common and documented. But yeah, the SPs would be good ones to build up to. I'd say I wouldn't start with them. The chips are, it's all semiconductors, so it's literally, if you look up how semiconductors work, or is there a good program on how you probably want to almost look at, like, I don't know where you want to start with that, because basically all the chips work on the whole principle of transistors. They're all millions of transistors for the most part, the semiconductors. That's what kind of started the entire computing boom. So you've got resistors, caps, they're called passive components, they don't do much, the passive, as they say. And you've got semiconductors, which are your transistors. The fact that you can turn something on and off electrically between two states, or variably for analog, gives you infinite control to then build up from millions of ones and zeros, which is what these chips have. They just got tons of transistors in there, as well as other parts of the circuit, caps and resistors inside. But ultimately, yeah, it's just a bunch of transistors that allow you to have state machines of ones and zeros that react differently, and that's how everything's built up. It's all building blocks, and there's a million ways of taking transistors and turning them into anything. So inside the black die, we'll try and crack one open if this works, or, well, to be honest, if this works or it doesn't, I haven't got another one to try it on. We'll quickly see if we can crack one of these open and show you inside. Ah, bad VDP again. Oh well. Well, we know that's built and we know it's the VDP, but I've got none left, so let me just put a cross on him. It's crazy how many VDPs are bad. But that's that. So yeah, I'm gonna have to rob eBay now of all the Game Gears. That can go back. Let's just tidy this desk up a minute. I might have a Game Gear somewhere actually that I could find a chip on. So what was that? Two bad VDPs, one good VDP. That's quite poor. That one's all working, but the VDP's bad, so unless we can find another Game Gear somewhere, maybe in the games room or somewhere, and then all we've got to do is chuck that on. I don't know, let's see if we can find one. I've probably got one in the games room still, haven't I, on the shelf, I think. That'll be the last one we've got, I'd say. That's that. So inside of here, let's just have a go at cracking one of these open, I guess. Yeah, we plan to remake these chips as the goal. Hard to boss the family, they don't listen. I've tried for years. So yeah, it was hard when I'd argue and fight myself to get people to listen, but no, people well, I say people, mostly all people, but family are worse. Obviously, you live with them and they don't like to be told what to do like nobody does. So I give up on that now. They do pretty much do the job, and if we survive, we survive. If we don't, then they're out of a job because it's their job they've got to do. So I kind of take a laid back approach now on managing, just let them get on with it, and they'll learn the hard way if it works or not, because if it doesn't work, I'll carry on and do my own thing. Basically, that's the idea. I could do with gripping this in some kind of vise. See, because what I want to do is heat this up and try and crack this. Well, the first thought is just crack this open to see the die inside and break all the legs. The other way is to sand all the top down. But if I want this to crack open, I could do with having it somehow where I can like heat it up and then break it. I do need a vise really. What can I do? I mean, this could be a really crude vise, but what if we just use this board we're getting rid of, and no, it's just going to melt, isn't it, when we heat it up? My idea, I mean, it'll help a little bit. My idea was going to just be chuck some solder on this board here, tack some pins on there, just to keep it in place, basically like that. And then I've now got a kind of a chip floating on the board that I can sort of hold. But as soon as I start heating this up, that solder's going to melt and it's going to fall off. But I wanted to be able to kind of hold this like this, heat and bend. So we'll go for it anyway. But you just want to get this as hot as possible and literally destroy the chip to see if we can see what's inside to start with. A fork will probably bend and deform under the heat pretty rapidly, and then the coating will all burn off and stink. So and this will take a while, so start a time. This will be interesting for once I try to do this properly to expose the die. I'll ideally need to know rough amounts of time this will take to remove. Thanks Alan, glad you're liking the channel. See, there you go, that's just fell off that, so that's now not much use for us. Yeah, it's kind of annoying, I definitely need a wedge of some kind. There we are. So we're on 37 seconds. It normally takes a few minutes to... We're not exactly decapping in a sense here, we're just destroying, but we just want to get the silicon that hot so that we can crack it out of there. In fact, if I do that, I kind of tilt it down and apply some pressure. Base knowledge in electronics, I started by having an idea. I wanted to, well, I was a software developer, still am. So the first thing I kind of dabbled in was PIC chips by Microchip. And this is also, if people are wondering how delicate these chips are, we've had 500 degrees at 120% airspeed for a minute and a half at point blank range on this, and it's still not broken, it's still not damaged or burnt. So these are very durable. For getting into hardware, I started with microchips because I was a software developer, so I wanted to, make code do something real. And at the time I was working, as well as having a business, I was working for companies. I did that for a few years when I was like very early 20s. I'd run Angel 6, but I'd still work for people to bring some money in until it brought enough in. And I was working for a trailer company, so big Arctics that transport stuff around. And I don't know whether they've even fixed this problem yet, but the issue was with like blind spots in trailers. So I wanted to make a product where the driver could have a device up front in the cab that lit up lights if there was cars in the blind spots, and put LEDs alongside where the cars were, so I had an idea of what I wanted to do, and then I'd just research generally, you know, how would you detect distance or how would you detect objects, and read up about infrared sensors, ultrasonic sensors at the time, and then learnt about PIRs and, you know, different forms of detecting objects, and attempted to make just a device that read, it's getting a bit flexible now, tried to make a device that would read the ultrasonic sensors, and the first stumbling block was trying to drive an ultrasonic sensor to make a pulse, because it's, you know, an audible sound you can hear, and that turned into trying to learn about transistors, because you need to then boost the current and send a pulse from a microchip to power something of higher current. Then that led down the route of blowing up. Literally, when I say I learned electronics by blowing up transistors, that's what I did. I used to go Maplins, buy all the stock of transistors, tried to figure out how they worked, exploded in my face 20, 30, 40 times. Still don't really know transistors that well. I've built plenty of circuits on them, and I've done a lot with more MOSFETs, but yeah, the main way I figured it out was, like I say, just having a goal. I think that's the main thing you need. There's no point, well, for me at least, there's no point being taught book smart. I want to learn by having a goal, and then instead of saying, no, what do I want to learn, you know exactly what you want to learn, and you start investigating yourself where you need to go. But it's just a lot of experience built up on top, basically. So there you can see the first glimpse inside of this now of the circuit. So I want to try and open this out if I can without destroying it completely. But that took 4.5 minutes at 500, and you can see this just cuts through now, nice and soft. So let's let me focus a bit higher up so you can kind of see this. I want to still do it while it's warm though, if I can. I don't think it's going to focus. Maybe is it going to focus there? There we go, so you can see a bit more of it. Yeah, this is already cooling down, we're probably going to have to warm it back up. But it seems like the cutters work quite well, to be honest. Yeah, when Maplins went, I had to start buying from DigiKey and paying £20 every time I wanted a delivery. So if you're ever worried about damaging these with heat, you definitely don't need to. These are very strong. And then you can see here, this is a perfect example of where the legs go. So if you see that big stick there hanging out, that is one of these legs, and it's going all the way through the silicon and then making its way into here, which you can start seeing the separation there. We might be able to separate this way, hopefully. And there you can see they have bond wires inside. And obviously this is, we're going to end up with like scratch marks and damage on this, but this is just an initial view, hopefully, to get you to see inside these. So I think what we'll do is warm that up and then use the tweezers to get further inside. But yeah, these are the bond wires here, these little gold flakes here. And those bond wires that are flexible connect to these larger legs that go on the outside. So most of the time when there's damage, it will be these metal legs connecting to these bond wires fracture. And you can grind away the top of this to get inside and see all these legs, and then reattach the bond wires. And then this little bit you see here is the actual the VDP itself. There'll be a little rectangle here which will be the actual logic, all the transistors and the silicon, basically. This is already dead, so somebody was interested in what was inside of these, so I figured we'd just crack one open now to try and see inside, to show you a rough idea what is inside them. But this was already a dead VDP. You'll notice as well that the RePCB's been subject to 500 degrees Celsius for 8 minutes and it's still white. That should be nice and warm. Well, it was warm until I couldn't grab it. There we go. So this is the silicon die here. See this exposed part? So we've found the area where it is now, so I should be able to lift this off. We can get this out of the way. So it's a perfect time to show there then. So these are the legs that we've seen, and you can see one of them can go really far like this. And then this is where it starts to be bond wires, this where it gets tighter. These bond wires then go through here into this rectangle here, which is the silicon die. So the main heart of the chip is this rectangle you're seeing here, and everything else all around it is just carbon, silicon, and the legs. So you can see that leg there now comes out, and it's just going into the bond wires basically. So they go into bond wires here, which are super fine, and then into this chip that we want to try and expose. So let's just heat that up a little bit more now, and then we should be able to get this off and give you an idea of what's inside. The encase them in carbon and silicon for both of them reasons. One, to dissipate heat, and two, to keep everything structurally together. So there I've separated the two parts of the die there. We've actually separated the two layers, and the top, what we want to look at, still covered by this. What you'll actually see on, so you see there's the bottom of it, and that's stuck onto this is just a heat plate there. That's probably a ground pad, and that is literally attached to there. So this will be, I'm sure we got the pin out of this and went over. This is actually a thermal ground pad inside here. That's all that is, just solid metal. So we can get rid of all that. And this is the part we want. So we still have the silicon here that was attached to that heat plate, and we've got the chip under here that we need to try and get out. So I'm still going to warm it up a bit more because we want to try and lift this off so we can see something useful. Yeah, so if you get the some of the original Game Boys have just a blob of black paste over some legs, and it's basically, before you make a mass-produced chip, you can just put this silicon die straight onto the PCB and have bond wires soldered straight to the board, and that's what you do before you mass-produce things. So you can see that in the early Game Boys. So we're almost to it, but we've got still a little bit on there. I'm not sure whether we're going to get that off without acid, without damaging the chip, like without effectively just cracking it, but we'll see if we can get anywhere with this now. Yeah, I think that's too adhered to that to do it the this crude way, if you will. But what you'd normally do at this stage is you can either heat it up and it cracks off normally clean, but this is quite adhered. You can use some acids to dissolve the. I might keep this because if I pull this off now, we're almost likely going to just crack this, so you're not going to see much useful. But I can look at what acid you typically dissolve it in. It's probably similar to what you dissolve PCBs in when you're etching them manually. We might do this properly and try to, that's as zoomed in as I can get, try to get this so you can see something useful. But you can see there, there's where the bond wires attach. So all these little dots here, these little pads, are where every single pin of that ASIC attaches. So that's where all these pins here come in. So every one of these legs comes in through to these bits, and as we saw then in like this bit gives you a good visual, they come in 2 legs, and then from here, which is the other side I believe, oh, that was the right side, this chip obviously sat on top of this one like that, and there's basically bond wires. So these little gold wires, you can see them still attached there. So these bond wires here, these little gold things, they solder to them. We can still solder to these pads. We could literally take this chip now and solder every pad one at a time to the game gear and potentially get it working if the fault was a bond wire fracture. But you imagine how long that takes. It's doable. So if you counted all these pins, these would add up to the number of pins on the ASIC, and you can literally hand wire them. But yeah, these gold wires fly over, attach to these pins, and then these pins go out there. But if we expose this, you can just about see it here. You can start seeing the little bit of the main silicon that you want to see. So I'll pull up a picture, I think, of what you will expect to see. And then I'll order some acid that will dissolve this properly so you can see. Because it's always good to see it yourself versus a picture online, but let me try and get a clear image of what you might see. So this one, pull it over to the right screen. I've just typed inside a silicon chip, for example, to try and get an image where it shows something good. Yeah, this one's not too unclear. If we go to PC, and of course the PC bit's failed, let me do screen capture, toggle back and forward. There we go. So this is, you can see around there, that is like the chip that we're looking at. So if I was to, let's say, superimpose this over and then get this chip, and you can see if I move that out of the way, so this chip we're looking at here is basically the same as this outline here. So this outline of dark inside the yellow is like this actual chip, and these little gold wires are the little gold wires that you've seen flying out to the edges of the image, and then they attach to the larger pads. So if we looked at that, you can see these larger pads here, all the way down. Those are the legs that you see in here. So these are these legs here. So that's the principle of where we're at. And then when we uncover this, you'll see inside the chip, which is then, they'll all look different, but these are the machines they've used. So in that case, they've just used, by the looks of it, a normal camera to do the close-up photography. If not, it's an excuse for me to buy like a metallurgical microscope and then hook it up to HDMI so you guys can see literally what's inside this chip. But if they zoomed in, this is where you'll see things like the etched writing and you know, all this detail like this is what you should be able to see. But some of them you need scanning electron microscopes. I'm sure we can get, with how large these will be, the Game Gear, they won't be that small. I'm sure we can use just a normal microscope in a sense, like a normal lensed microscope to see inside this. But for now, let's keep this. This is the obviously the VDP of the Game Gear, and we will get some acid to erode this, and we'll probably have an almost complete VDP there. I don't think we've caused any damage as such to the actual chip. I think that is structurally, and this is literally my lens maxed out, that's as close as I can get with my lens. It is tiny, like you can see me, it's literally the size of my fingernail. I don't think we've caused much damage of any there, so we should be able to successfully etch that out and see it. And I know you guys have been asking for that, you've been wanting to kind of see that process for a while now, the whole what's inside of the chip, but even though I know what's inside, it's always good to kind of show you and basically see how you do it. Just a bit of hot air and cutting it open, and that's what you can get. When you get to a corner pad, how do you know which side it is? You can either look at what's going on in this chip and figure out where ground is, or we could always break one specifically, another one, and find out the orientation. So once you know visually what this looks like, you know which corner it is. But at the minute, I wouldn't have a clue. This is the first one we've kind of delidded. No, these would have been made by hand and by machine. They'd get a silicon wafer, so a circle disc. They'd etch it out multiple layers. The whole factory would have done this. So these were always produced by factory. And then obviously machines just attach little bond wires going over. You can watch that on YouTube. If you typed in like bond wire machines, you'll see little machines that just grab the wires and just literally dot them over onto the chips. Recreating this, if we're looking at cloning this in a sense, you can basically get to the point where you can see the chip. So when we can zoom in, you can see all the parts. They're all just made up of transistors, and normally every chip is pretty much made up of D flip-flops, which is just a bunch of transistors aimed at creating a very basic circuit. And then there's just thousands. This will probably have like 100,000 gates on, and then you can change that into what's called a HDL language, so a hardware descriptive language to describe what this does, and then you can have it fabricated like Sega would have originally. You can just literally have it remade. It just costs a lot of money. For how to make them work, again, that goes down to pretty much fundamentals. It's building blocks at the start of understanding how transistors work, and then how logic gates work. You start with ANDs, ORs, NOTs, XORs, all those kind of gates. Then you make flip-flops out of that, J flip-flops, JK flip-flops, D flip-flops, and then from that you can build up to CPUs and everything. So a hell of a lot of stuff to learn to build it up to that, but ultimately it's all based on the same principle. Right, so that's it for this one, guys. I'm going to pop out now anyway, and I'll catch you in the next one.